So I can only see what's being presented, what you guys can see. So don't worry about if you're seeing or whatnot. So, all right. So today we're doing 115 zeros of polynomials. All right. So zeros again are where the graph crosses the x-axis. All right. They're also called roots and solutions. So if I fill this in, the x-intercepts of a function are also called zeros. They're called zeros because that's the y value on the x-axis. Y is always 0 on the x-axis. All right, and then a polynomial function of degree n. So for example, we'll say if it's x cubed, can have at most n real zeros. So something that's x cubed can only have 3 real zeros. All right, and then an even degree polynomial has an even number of real zeros or no real zeros. And then an odd degree polynomial will have an odd number of real zeros. Okay. So next we're talking about linear. So we've got to do some vocabulary before we get started, so it makes more sense when we're doing it. So we have linear factors and solutions. So the solutions to the equation. All right, so we set the equation equal to 0 is what this is saying here. In a different color. These are the zeros of the function. They're also called roots. Pretty sure I talked about this in another section. All right, and then when we get our answers, we say x equals c is a solution to the equation. Then the factor x minus c. We consider this a linear factor. And linear factors are found by factoring the polynomials. So basically what we're talking about right now is factoring the polynomials. So they're in their factored form. And we're going to set those factored form equal to 0. All right, so example 1a, we're going to find the zeros of this function by factoring. And when we factor, the first thing we're going to always look for is a greatest common factor. So x cubed plus x squared, or 3x squared minus 10x, they all have what in common? No, okay. They all have an x. So my greatest common factor here would be considered x. So what I'm going to do is I'm going to factor x out. So it's basically dividing by x for each of these terms. Then I have x on the outside. We get x squared plus 3x minus 10. And then from this point, we're going to factor the trinomial that's in parentheses. So my first term times my last term will give me negative 10. Then I list my factors of 10. We got 1 and 10, 2 and 5. And that's it. So we need to figure out which pair adds up to positive 3. And it has to be a plus minus combination because that negative 10 at the top. So the combination is going to end up being a positive 5 and a negative 2. Because negative 2 plus 5 ends up being positive 3. So when I factor this out, I'm going to get x minus 2 and x plus 5. So we've done this plenty of times already this school year. We have our factors. You don't have to do slide or divide because the number in front of x squared is 1. So the next part, we're going to set these equal to 0, and we're going to find each of our factors. So if x equals 0, x minus 2 equals 0, x plus 5 equals 0. And from here, we're going to solve each equation. So x equals 0 is done. I'll add 2 to each side for this other equation. So get x equals 2. Now I'll subtract 5. So get x equals negative 5. And that's done. All right, I'm going to list my answers in set notation. So my squiggle brackets. If you can't draw them, just sneeze, and then it'll draw a squiggly line. So it doesn't matter the order. I like to write it from lowest to highest. That's negative 5, 0, and then 2. All right, so these are the zeros of this polynomial function. So if we were to graph it, this function would touch the x-axis at negative 5, 0, and 2, which is what we did in the previous section. All right, sliding over to B. We haven't done one like this yet this year, but it's just like a normal quadratic equation. So there is no greatest common factor. But I want to factor it like I would factor anything else. So I'll take first times last. It's going to give me 4x to the 4. I get 1 and 4, 2 and 2. Factors that at negative 5 would end up being negative 1 and negative 4. Because negative 1 times negative 4 makes positive 4 when you multiply, and then negative 1 minus 4 adds to negative 5. There's a bit of a catch here. I'll put the numbers in first before I go to the variable. When we do x squared, I pan back to the left here, x squared breaks up to 1x there and 1x there because x times x makes x squared. It's an even number, so we have an even exponent, which is nice. But do the same thing with x to the 4. We're just going to cut the exponent in half. So half of 4 will give me x squared and x squared. And that's how you factor a quadratic style equation of degree 4. Now, the next thing here, these two terms are factorable. It's called the difference of squares. So since there's no middle term, and 1 is a perfect square, square root of 1 is 1. So we get plus 1 minus 1. That's how we end up with 0 in the middle, because 1 minus 1 is 0. And our next pairing will be plus minus. Square root of 4 is 2. All right, so it's a little extra step in the factoring part, a little tougher, I guess. But now we have our linear factors. I'll set this equal to 0, and I'll solve. So x plus 1 equals 0, x minus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0. Solve each equation. We get x equals -1. Simple linear equations here. So I get x equals +1 now. And I get x equals -2. And then x equals +2. List all my factors in ascending order. The -2 is the smallest, followed by -1, followed by +1, and then +2. All right. Next thing we're going to talk about is multiplicity. So sometimes when we solve equations, we get a repeating answer. All right. And it still only crosses the x-axis one time at that spot, but the answer repeats itself. It'd be something like x minus 1 squared. When I solve this, I get 1 2 times. So we say that I have a multiplicity of 2. I'll talk about that in the example. All right, we're going to do the same thing here, but there's going to be a little twist to the types of answers we get. So we have f of x equals x cubed plus 10x squared plus 25x. I'm going to look at my greatest common factor, which is x for this problem. I'm going to factor out an x first. Divide all these terms by x. And I'm left with x squared plus 10x plus 25. Now we factor. All right, GCF up there for the notes. So I looked at first term times that last term. I'm going to get 25. Factors of 25 are 1 and 25 and 5 and 5. We don't have a lot of choices. So 5 plus 5 makes 10. Now we're going to solve each of the factors like we did before. First one's done. X equals -5. Same thing here. X equals -5. So we have x minus 5 2 times. So we have our answers are x equals 0. We say this has a multiplicity of 1, because there's only one answer, which really isn't a multiplicity then. But for example's sake, we're going to talk about it. And our other answer is x equals -5. Since it repeats, we don't have to write it twice. And we say it has a multiplicity if you want to abbreviate it as multi, that's fine. All right, so because there's 2 answers, we say multiplicity of 2. And because there's 1, 0, we say it has a multiplicity of 1. And that's all multiplicity is when we're talking about it in the big picture. All right, moving on to B. So looking at B, I want to get rid of this negative out front. So I'm going to divide everything by negative. And then each term has an x. So I got x's I'm going to take out. And then the lowest exponent of all the x's is x squared. I'm going to factor out x squared. So that means my GCF is negative x squared. All right, so working it down, negative x squared comes outside the parentheses. 4 minus 2 gives me x squared. And I get negative 6x plus 9. Now I'm going to factor what's inside there. So first times last gives me positive 9. Factors of 9 are 1 and 9 and 3 and 3. So to make negative 6, got to make both of these negative. All right, so I have negative x squared, x minus 3, and x minus 3. Now we'll solve. All right, so we're solving these ones out. I'll divide by negative 1. I get x squared equals 0. Take the square root of x from both sides. So x equals plus or minus 0, which doesn't make any sense. But that means we have 0 not once, but twice. So we have 0 has a multiplicity of 2. All right, and then we solve these guys out. They're going to end up being the same answer. So then we say x equals 3 with a multiplicity of 2. All right, so that's using algebra to do it. And that's all we're just expressing our answers is how many times we would see them. Now, graphically speaking, we're given the function. Let's see, you guys catch up to my screen. F of x is equal to x cubed plus 4x squared plus 4x. I will give you the factored form as x times x plus 2 and x plus 2. At this point, you have technology, all right? So you can go on the Desmos and you can graph it. So I can do that. Go. So it's x cubed plus 4x squared plus 4x. All right, so this is what your graph looks like. Big points we need to look write down, where my zeros are, my x-intercepts. And then I also want to know where this bend is at. I'm going to write this down on the notes, but this is how I would do it. I would just use Desmos or graphic calculator, and I figure out what the graph looks like. All right, so the graph, we know it crossed at -2. Right there's one of the points. Then an x-intercept at 0. And then the other point down here will be at -0.67 and -1.19. So the -0.67 is in between 0 and -1. And then it's going to be just below -1. So the bend is right in that vicinity. So looking at Desmos as a reference, I would see that it does this. All right, and what's going on at this point right there? We are tangent to the point. That's not very visible. It's not like a tangent function. It is tangent means you touch. So it touches that point, but doesn't cross through it. And at this other point here, it intersects it. I-N-T-E-R. So it intersects at 0. Now, why do I say this right now? Because the next part down here is when multiplicity is even, okay, the graph is tangent to the x-axis at 0. Now, if we look at my factors, I ended up with x equals -2. That had a multiplicity of 2. And on the graph, at x equals -2, it just touches that point and doesn't cross through it. But then we had x equals 0, so that's considered an odd number. No, I'm sorry. 0 is not considered odd. The multiplicity is 1, or of 1. So that means we intersected it. So when the multiplicity is odd, the graph intersects that point. Intersects that point. All right, so we need these two things to talk about the tables we're going to look at next. All right, so let me zoom in. This one's already factored out for us. All right, so I have x minus 1 quantity squared, which means this is x equals 1 with a multi of 2. And then if we do 2x minus 3 equals 0, we got to solve this one, a little extra step here. Get 2x equals 3. Divide by 2. I get x equals 3/2. And since that's quantity squared, that means we have a multiplicity of 2. And then you got the x plus 4, which ends up being x equals -4 of 1. So everything I just wrote, basically we're going to translate to the table. All right, so my zeros, if you want to write it left to right, that's fine. Our first 0 ended up being x equals 1. And that had a multiplicity of 2. So using our definition above, since it's an even multiplicity, that means it intersects. I'm sorry, it's tangent. All right, now our next 0 was positive 3/2. We had a multiplicity of 2 with that. So that means, graphically speaking, the line of the graph will only touch it, be tangent to that point. And then our last 0 for this one, -4 with a multiplicity of 1. And this one intersects. All right, and then last one, got some work to do. I'll write it all out for you. I've done a lot of factoring already today, so our final answer for this one will end up being x cubed times x plus 4 squared. So when that's all factored and said and done, that's what it looks like. All right, so what that means is x cubed would end up being x equals 0. So we have a 0, or 0 is 0, with the multiplicity of 3 because it's cubed. And then our x plus 4 quantity squared will be x equals -4. And since it's squared, there's a multiplicity of 2. And the effect on the graph, 3 is odd, so that means it intersects that point. And then 2 is even, so at -4, it'll be tangent to the point. It won't cross through. All right, so then for the assignment, it's basically everything we just did. All right, so 1 and 2 you have to factor. And then for 3, 4, and 5, you just have to graph it. And then find the zeros that way, and then their multiplicities. And then 6 and 7 is what we just did with the table here. So you should have a table for numbers 6 and 7. And that's all I have, barring any questions.